So today we're going to be talking about another way to organize data, and this is frequency tables, line plots, histograms, and these are ways to organize data for which given occurrences happen more than one time. So like a frequently occurring event. So for example, here you got Sydney's math test scores are 90, 85, 88, 100, 77, 85. So you could already see 85 happens twice. So if you want to put this data in a table, we could just say like how many times was this score obtained, how many times was that score obtained. So the frequency table is the easiest way to do this. So you take the score in one column and the frequency that score is obtained in the other. Very simple idea. So in this particular case, there are scores of 77, which I can see happens 2 times. I got a score of 80, which happens 1 time. I got a score of 85, which I can see happens twice. I got a score of 88, which happens 1 time. Then I got 90, which happens twice. I got 95, which happens once. And then I got 100, which happens twice. So looking at that, that's my frequency table. So again, the number that you see here represents the number of times that score was obtained, not like the score or anything like that. It's just the frequency that score was obtained. So in this particular graph, I'm going to try to erase. Just make sure. Oops. So I'm just going to kind of erase this so I can draw on top of it, because the histogram is a little bit of a bigger graph. So if I'm looking at this one, so I'm going to make my y-axis the frequency and the x-axis are the scores. So I'm gonna start the scores. We're gonna keep this at we'll say that this is about 70 right here, and then this top is 100. So when you do this, you're just gonna kind of organize. I'm gonna count up by 5s. So let's say 5, 10, 80, 15, 20, 90, 90, 100. So let me just kind of erase that, make this table nice and neat. So if you got all these scores, so I got a 77, which happens 2 times. So on my frequency chart, I'm going to go up 1 to 2. So I got a bar graph essentially that shows me that the score of 77 happens twice. The next score is 80, which happens once. All right, the next score is 85, which happens twice. And you can see it goes on and on like this. So it's just a different way to represent the frequency. 88 happens once. 90 happens twice. 95 happens once. So 95 happens once, and 100 happens twice. So when you put it in bar graph form, you can see that a lot of the scores happen kind of like you see the frequency happens a lot around here in the middle, between 85, 88, and 90. So most of the scores, 5 out of the scores happen between 85 and 90. So it's kind of where most of the scores lie. A line plot is a similar set of data. So it's just going to be kind of the same thing. I'm going to start my graph at 70. And go up. So let me just backtrack a bit here so I can make this. So instead of a bar, you just kind of put dots or X's. So for example, 77, you would just put two little X's or 2 dots that represent that happened twice, right? So you can kind of see that this is going to be like a stack chart. So you can see 80 happens once, 85 happens twice, 88 happens once, 90 happens twice, 95 happens once, and then 100 happens twice. So you kind of see it's sort of the same data, just a different way to represent the frequency that data occurs. So let's look at a problem that kind of involves this and some of the questions that you might be asked about this. So test scores were organized in the following table by their frequency. So it says score 75, 76, you can see how many times, and then this represents how many times that score was obtained. So represent the data in a line plot. So taking this data, I'm going to just kind of do what we just did, where I'm going to graph a line. I got at the low end, I'm going to put 70, 85, 90, and then 95, 100. And then I'm going to plot these frequencies. So 75 happens twice, 76 happens once, 79 happens once, 80 happens once, 81 happens 3 times. So you can see that you stack them up. You can see that frequency happens a little bit more, makes a little bit more of a taller graph. 82 happens once, 85 happens once, 88 happens 1, 2, 3, 4 times. 90 happens twice, 91 once, 93 happens once, 96 happens twice, 98 happens once, and 100 happens once. So there's my line plot. So again, a histogram is a very similar situation where I'm just going to put like the y-axis is now going to be the frequency, and the x-axis is the score. So right now, I'd like you to try to draw this histogram. So I'm going to pause it, and then we'll come back and see how you did. All right, so here's the finished histogram. It looks very similar to the line plot, it's just a bar graph form, and it gives you a good indication of the frequency that scores occurred. So part C asks how many students took the test, what is the median score, the mean score, and the mode score. So in order to determine this, taking your frequency table and then interpreting these things requires you to list out all the outcomes. So when you do that, it's actually pretty easy to do, but if you just look at, you're just gonna list them out by how many times they occur. So 75 happens twice, 76 happens once, 79 once, 80 once, and then you got 81 3 times. So again, I'm getting all this data right from this table. It's probably the easiest place to grab it from. So I'm going to do 82 happens once, and then 85, and then 88 happens 4 times. And I got 90 happening twice. I got 91, 93. 96 happens twice, and then 98 and 100. All right, so if I count these up, how many scores are there total? One way to do this is just to add up all these frequencies. You can just take the sum of all these. So if I add 2, 3, 4, 5, 8, 9, 10, 14, 15, 16, 17, 18, 19, 20, 21, 22. So there are 22 total. So we could write that somewhere just so that we're not losing that number. So 22 total students took the test. So now it says what is the median, mean, and mode, right? So the mode's very easy. So let's just do median first because we got it listed. That's probably one of the easiest things. So if you got 22, you got to average the 11th and the 12th. So if I'm talking about 22, I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And the 11th and the 12th are the same, so the average is just 88. So that's pretty easy. The mean is probably the most difficult. So that's going to require me to type all these numbers into my calculator, divide by the number of numbers, and that's going to be my answer. So we'll do that in a second. I'll do that off to the side. I'll pause it and have you guys do that too. The mode obviously is pretty easy too. In a frequency table, the mode is the easiest thing in the world because you just look at like, well, what is the one that has the highest frequency? In this case, 88. So mode and median are both 88. And now I want you to pause it, see if you can determine the mean, and we'll come back and give you the answer. All right, so I figured out I got 1901 when I added up all the numbers, divided by the number of students is 22, which gave me 86.41 as my mean. So I'm pretty sure that's correct. Check my work. Again, I did that quickly. I'm looking at it again, but it looks like I probably got that one correct, just making sure. And again, with this one, you type that many numbers in your calculator, a lot of opportunities to hit a wrong button, to miss a number. So just make sure you're checking your work, and that's a good thing to do. So that's your mean, median, mode for that set of data. All right. All right, so here's one that I want you to try, obviously. You got a histogram, the number of seeds in each of 12 apples. So basically, yeah, so organize the histogram above in a number set. What I mean by that is just you want to make a table. So make your table. What is the mean number of seeds per apple? What is the median number of seeds, the mode, and the probability that a random has a set of 7 seeds or more. So I'd like you to try this one. We'll pause it. work it out, see if you can figure this out, and then we'll come back. So here's your data. Pause the video, and then we'll come back in whenever you're finished. You can hit play. All right, so here's the frequency table that we created from the histogram. You can see. So the number set that I had to create to find the median and well, basically just the median is this. I used the frequency table to create that. So you can turn a histogram into a frequency table. I could turn the histogram into a number set. So this is actually a number set. So I got 3, 3, 5 happens 4 times, 6, 7 happens twice, and then 9 happens 3 times. So the mean is the average of those 12 apples as far as the seeds are concerned. The median is the middle term. So in this case, it's 12 numbers, and 5 and 6 are the 6th and 7th numbers. So you had to average those two to find the median. So again, when there's an even number of numbers, you have to average the middle 2 numbers to find the median. The mode is clearly the easiest thing to find in a frequency table because it's the highest bar, in this case 5. And then probability the apple picked at random from this set has 7 or more seeds. There are 1, 2, 3, 4, 5 that have 7 or more seeds out of the total, which is 12. So take a sec, pause. Obviously, hopefully this makes sense. This looks hopefully going pretty well. Frequency tables are definitely something that you're going to see on the SAT and things like that. So. All right, so here's your homework. This is also linked in the assignment. It's titled 11.1C Part 2 homework. So I'd like you to try that homework, look at the problems, and obviously pause the video right now, and I will go through these problems momentarily. Just pause it, try it, see if you can do these just for more practice so that you know what you're doing. All right, so let's talk about this worksheet and just kind of go through some of these questions. If you have any issues or anything, feel free to email your teacher or me. All right, so you got a line plot to display the data. So you got all these ticket prices. So here's a line plot that shows you the frequency that each ticket price was obtained, and basically it. I mean, you draw the tickets went from $30 all the way up to $73. And you just kind of mark X's indicating frequency. And then using that frequency table, you can answer these questions pretty easily. So how many ticket prices are 50 or less? So clearly looking at the chart, you can see 50 or less is right here. So there are 1, 2, 3, 4, 5, 6 tickets that are 50 or less. It's pretty simple to look at from the chart. If I had to look at this data set, it might be a little harder. I might miss a number if I don't have it. Stem and leaf plots are something you learned in Algebra 1. I know this because I've seen you guys working on it, but it's maybe a good review. So basically, stem and leaf plot, the stem is the first number. So this would be like, in all these ticket prices, you got a $30 up to $73. So $30 ticket price happens twice. So the stem is 30, and then 0 is the second number. So 30 and 30. So this would be 42, 47, 49, 50, 54, 54, and 59. So this is just a different way to represent data. It's kind of like a frequency table, just, a little bit different. Easy to recognize median, easy to recognize mode. It's a good way to organize your data in a fashion that's easy to understand. So now based on that and based on your numbers, what's the range of the data? That's the lowest and the highest, and the difference between those, in this case 43. All right, moving along. Another thing that we didn't talk about was histograms and using a range of data. So in this problem, it says use the following hourly wages and then draw a histogram. Begin with the interval $5 to $6.99. So there's my first range. So then I made the other ranges kind of reflect that same range. It's like a $2 range. So this would be $7 to $8.99, $9 to $10.99, $11 to $12.99, $13 to $14.99, and $15 to $16.99. So these are like these aren't tickets. These are the hourly wages. So if you wanted to look at these are all dollar amounts here. So if I look at, this is dollars that somebody's making per hour. So then they listed all the hourly wages here, and obviously you can see I crossed them off as I counted them. But people making between $5 and $6.99, there were 6 of them in this set. Between $7 and $8.99 an hour, there were 5, and then so on and so forth. So again, you can do this with a range. You don't have to do it with individual numbers all the time. So again, with a histogram, a lot of times you're going to see these ranges as your x-axis. And then obviously the y-axis, I didn't label it, but I should have, is the frequency somebody fell within that range. So between $5 and $6.99, 6 people fell in that range. So I made a bar that was 6 high. and that's the highest, and then on down. So then the next questions ask you to answer some of the things about this. So for 6, says copying completes is the greatest number of employees earned from blank to blank, so that would be 5 to 6.99 an hour. And then it says copying complete, about half of the employees average have an hourly wage of blank or less. So in this case, there were a total of 19 employees, and this is where it's about half, but about half make $8.99 or less. So about half make $9 or less. So looking at the frequency table, I got that data. All right. Number 9, it says most people surveyed receive an average of blank emails per day. It's just, because these are average emails a day, it's 4 to 17 emails a day. I did the mean was 9.08 for the data set. So the average of the averages was 9.808. This is how many people receive an average of more than 10 emails before. So more than would be not 10, but more than. So there's only 4. There's 1, 2, 3, 4 of those people. So again, when you have a line plot, it's pretty easy to pick that data out of there. Here's a stem and leaf plot. So again, this would be 22, 25, 25, 29. So it's the weights of dogs all the way up to 65. So it says how many dogs were in the shelter. So this would just be counting. It tells you here, but you just count the numbers. So it's like 1, 2, 3, 4, and then count them all. There's 22 of them. Find the median. This is actually pretty easy. Once you know there's 22, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's the average of 41 and 42. Obviously 41.5 is the median. The range is the difference between the first and the last number. So in this case, that would be 43. All right, lastly, you got this histogram, and answer 3 simple questions about it. So which age group had the greatest attendance? Clearly, you look at the highest bar, that would be 10 to 19 years old. The lowest attendance, so the smallest bar is 50 to 59 years old. How many children up to the age of 9 years attended the baseball game? So this would be 0 to 9. So then each of these represents about 10, right? So that's 10, 20, 30, 40. So since this lands between 20 and 30, I said 25. This is about just graph reading. Which age group had the same attendance as the oldest group? So the oldest group here, so you follow that line back, and that would be the age group 20 to 29. So hopefully this is easy. Try the work on that's assigned by your teacher, and hopefully this is good. You're ready to take a test on it.